How do you get out of suspension ledger as well? I think I want to. Like, as we're sharing your screen, remotely, so I don't want people to see. We can just do. You just do the window. Exactly. Yeah. Cool. So let me do this.
Like the live
This just going to be the. This is just local, and then so if you go to Airbnb, it's just showing just that window. So this will show the same. Because this is showing right there.
Because I shared this with him, he asked for access. This was 3 days ago. And if this is really P1, yes.
You could do the PowerPoint. Yeah, these won't transfer. PowerPoint's like
There's the spin-off 3 days ago.
I can also.
Yeah, we did. And she basically gave us some resources that we can look into.
Yes. FinOps. I think FinOps is also part of it. FinOps is also. Yeah. And their FinOps is all around the
side on the bottom.
How
Well, I mean, there's not going to be a way to do that. You just have to share this is going to be that whole screen, right? Yeah. So yeah, I mean, it doesn't, and I assume this will be the same. Yeah, it doesn't work with all the stuff there. So I guess let's just do it. I'll just wing it. I remember my best. Sorry about that. Why aren't they aligned with
So what is FinOps? I haven't heard of that.
FinOps.
I have no idea what Okay. Oh, financial.
Yeah, it was just it's a foundation.
No.
Yeah, this is
Which is
a
hard thing to do. Yeah.
It's industries now.
The next line, like basically, I had a way I can see presentations.
Right. Oh, yes. See, nobody's expecting anything from All right, ready when you are.
Yeah, you tell me.
Okay. All right, we're going to get started. There probably will be people filtering in. So thank you all so much for your time and attention, and I'll turn it over to Ben.
Okay, do I talk into this?
Yeah.
Do I? Oh, here? Okay. Word. Okay, cool. All right, I'm going to talk about this stuff. Okay, so a little bit of background about myself. I'm one of the, that doesn't work. Well, there it goes. I'm one of the founders of a company called Mode. Mode is a BI tool. It's designed for data teams. This is what it looks like. It also looks like this. You can create charts and stuff in it. Cool. That's kind of just a bit of background. About myself, so I am Mode's CTO now, one of the co-founders. At Mode, I do a number of different things. I work on product direction and strategy and kind of the hand-wavy stuff that founders kind of find themselves doing. Back in the past, I used to do things like running data and product and marketing and solutions and the other kind of random jobs that you find yourself doing at startups. I also will heckle the internet, Substack. I don't know, this is kind of my job now too. It's kind of got a Statler and Waldorf vibe to it. If you're interested in these sorts of things. One thing I am not, however, is I am not an AI or knowledge graph expert. So take all of these things with a very big grain of salt. I mostly don't know what I'm talking about, but I'm going to make some stuff up anyway. So this is kind of the context of this presentation, is I'm like a child who's wandering into the middle of this movie being this conference. I don't really have much frame of reference here beyond the stuff that I've done with like data teams and things like that. But I'm going to share some thoughts about kind of what we hear about when we talk to those folks. So instead of starting with the technical stuff, I'm going to start with, I'm going to start with a thing that I do know something about as being a tech founder from San Francisco, which is Tech Bros. So this guy is a tech bro. His name is Balaji. He's kind of famous on Twitter. He basically is like a real controversial guy on Twitter. He's very into Bitcoin and stuff. Most recently, he has kind of been famous for making a big bet, saying he bet $1 million, saying that Bitcoin would get to $1 million like last month. It got to 27,000, so like that much. Anyway, like credit to him, he really stuck to it. He's like, now on the hyperinflation and stuff like that. So if you hear his name, you're probably going to hear it in this context. But he does have some interesting ideas, and I want to talk about one that's totally unrelated to all this stuff, which is actually about mazes. So he had this idea that basically you can teach rats how to escape from a maze if you teach them to turn like every second turn. So if the right way to escape a maze is this pattern, you can teach a rat how to actually get out of it. So they go left and right, or I guess right, left, and so on. You can teach them slightly more complicated patterns like this, where say it's every third turn they go left. So these kind of basic patterns you can teach rats, and they will figure out how to get out of this maze. What you cannot teach them, apparently, is patterns like this, where they have to turn at every prime number. So if you had a maze that was designed to get out this way, no matter how much like cheese you stuff full of the rat, it cannot figure out that the next thing to do after turn 11 is going to be turn 13. Like it doesn't understand these sorts of things. And like probably, honestly, humans probably wouldn't either. If you put me in that maze, I probably wouldn't get out of there either. But there are these sort of patterns potentially that we can't see. And so this is kind of the point that ultimately he is making. That there are these patterns in the world that may actually be very simple or like very obvious if you understand what they are, that are kind of beyond our comprehension. That are things that define the way the world works, but are things that we can't see and we can't actually understand. And so there may be these sort of prime number mazes that we have figured out all these patterns that are the turn left, turn right, turn left, turn right. But when it comes to things like turning at every prime number, it's a very hard thing for us to understand. And so we actually have started to see these sorts of things emerge in the AI world. That there are actually these patterns in other places that aren't just sort of hypothetical mazes, but actually exist in other places. So this is a picture of Gary Kasparov playing Deep Blue. I think this was in 1997. When he first played it, one of the things he realized was it's tried to start to play like a human. It basically would make sacrifices and things like that in a way that machines typically hadn't. But it started to play in sort of these ways that could sort of see the future like a human. But actually what it was doing was it was like running all of these computations in such a way that was not at all human. And it started eventually developing strategies, especially when it started to teach itself stuff, developing strategies that weren't human at all, that were things that like humans couldn't even understand what these strategies were. And so sort of the more modern versions of Deep Blue is a company called DeepMind that built something called AlphaZero. AlphaZero is the sort of chess playing program. This is the guy who created it. And the way he describes it is, it's like playing chess from another dimension. That it seems to play these strategies that don't make any sense to humans. It does things that even like the best chess players in the world, and this guy's actually a pretty good chess player too, that we can't figure out what it's doing. Like it's making moves that don't make sense to us. And yet, it still beats us. Like it is a far better strategy than the ones that we play, but ones that we don't understand. And so the conclusion that he came to was, like, maybe our conception of chess is too limited. That ultimately maybe there is a prime number maze in chess that we can't see, that these AIs have figured out. And that is the strategy they're playing, and it's kind of beyond our comprehension as to what it's actually doing, but it's found this sort of superior path through a maze. And so this is actually something you see in other places where like AI programs have started to play games. So actually in the poker world, the same thing is true. There are now engines that will help professional poker players play poker. And the way they basically work is they run all these computations and then they eventually like say, here's the right move for playing poker. And the strategies that they pick out aren't things that are like obviously discernible for humans. And the way that people have actually started playing poker, the professionals have started playing poker, is using these engines and trying to mimic what the engines do. They don't even necessarily understand why it's doing that. They don't necessarily understand the patterns behind it. But the engines beat humans, and so they're saying, hey, maybe we should just mimic that pattern. That we don't understand what the prime numbers are, but we'll try to follow the prime numbers because the machines seem to figure it out, and it seems to be a superior strategy to what we have. And like this is now how professional poker players play to some degree. Obviously, can't mimic it entirely because the thing runs like a billion computations on different hands. But the point is, it's like people are now starting to play on strategies that don't necessarily make sense to comprehend them. There's not really a semantic meaning behind those strategies. It's just mimic the way the machine operates. And so we have a bunch of these other like semantic models that are similar to the ways that we play chess or poker or things like that exist in other worlds. We have things like semantic models. We have knowledge graphs. There are like financial models in business that we put together to say, here's how like the financials of a business work. There are various sort of operational models in businesses too, like marketing models that explain our funnels and those sorts of things. And what the question sort of I have, and the thing that these AIs seem to be able to do, is figure out what goes beyond these models. Again, we are playing the models. They're saying, hey, the way we design and understand these businesses and these processes are things that are the left, right sort of turns in the maze, as opposed to the prime numbers. And so the question is, are there prime number mazes in sort of the business operations that we run today? And so like that to me is, I think, kind of what a lot of these AIs and the sort of LLM type of models might start to figure out is, can we find these patterns that we don't see in the maze that they do? And actually it's sort of interesting that LLMs themselves behave in this same way, where the model that it actually runs, the way that it sort of predicts what to say next, the way that OpenAI and ChatGPT predict what to say next, is not something that understands human language at all. All it is a predictive engine of like, what word should I print next? And yet because of that, it's still able to do things that we don't necessarily understand. So the point here is like maybe our conception of companies, much like our conception of chess, is actually too limited. Maybe the only ways that we model these things, the way we make decisions as businesses, is all designed around kind of the patterns that we can see, but maybe there are other patterns out there. There are things that again, we can't quite pick up on. And so that's really what I kind of want to talk about here, is like maybe there is a better truth out there. I, as someone who doesn't necessarily understand these things, am sort of inclined to believe it. Obviously, again, take this with a grain of salt. This is not my area of expertise, but we see this time and time again in the way that AIs get deployed, is they aren't actually trying to follow the semantic models that we build. They're things that are able to figure this out in other ways. And so my question then is, like, what does this mean for the semantic model world, for the knowledge graph world, things like that? I have sort of three theories to this. I have like the small, kind of pleasant one, the medium-sized one, and then like the wild and crazy, more incendiary one. So I'll walk through these. That'll be kind of the way I wrap this up. Is here are the three various theories of what this might mean. So the first one of these, the little guy, the Charmander, is that actually knowledge graphs and semantic models become way more important. That if we're using these sorts of AIs and stuff and they become more mainstream, then this actually makes semantic models and knowledge graphs really, really critical to how we actually think about our businesses. So to explain this, basically, like the way that we make decisions today in businesses is often around things like this. We'll make dashboards. We'll do like various analysis. This is how, like, if you are a marketer, you might log in and check your dashboard and like, great, okay, I'm going to decide what to do with this. This is like somewhat accessible. It's like pretty easy for people to use, but as is sort of famous in the data world, a lot of dashboards get built and never get used. And so the hope is that instead of us like approaching our data this way, we start to approach it like this, where we just ask questions. We treat it like Google, or in this case, like ChatGPT, and we just ask it for what we want to understand. And this is a far more accessible model of understanding the world than say a dashboard with all these various kind of confusing charts. But as all of y'all probably recognize, like underpinning this, there has to be some understanding of semantics. That we can't just ask this question and assume a computer will know what to do with it. We've got to know things like, how do we classify different marketing channels? Like, what does a marketing channel even mean? We have to know, how do we actually use metrics to measure this sort of performance? If we care about things like return on advertising spend, what is the actual formula for that? How do we calculate, like, how do we relate these things? If we're looking at marketing spend in one sort of table or one data set, we have sort of customer orders and purchases and returns and all these other places. How do these things relate together? And then there's like various pedantic differences of like, what is a week? Does it start on Monday or Sunday, or in what time zone, and all these sorts of things. And so underpinning this has to be some sort of semantic model. Like, and if this is the way that we all interact with our data, and this becomes more mainstream than the dashboards, then semantic models almost by definition have to become more mainstream than they are today. Especially if, like, we start to treat computers the way they do in Star Trek, where we're all just like computer and it does a thing. If that is like our new interface into the computing world, then all of these things need these kinds of semantic models that will explain us how to do it. So, in one sort of telling of this story, the sort of AI future that we're all barreling towards is one where semantic models and knowledge graphs are the most important thing that we can have to actually make it work. But there's another version of this, which is the kind of middle story, which actually have to rebuild all these things. And the way we have currently thought about semantic models to this point kind of doesn't make any sense. And we actually have to recreate them for what this new future might look like. So what I mean by this, to explain this, is like talk about self-driving cars. So this is a self-driving car. It's a Waymo thing. I don't know. I guess I don't know what that is. Anyway, So these things are really hard. So if you've ever followed self-driving cars and like what's going on for the last like 15 years, they've been a few years away for a while. Elon Musk is kind of famous for saying like a self-driving Tesla is a year off for I think the last 10 years. Turns out we don't have them. Turns out it's a very hard problem. And it's hard because you run into stuff like this, where it's like, this is a confusing intersection. There's tons of things going on. There's all sorts of crazy road signs and stop signs and pedestrians and construction, and it's all terrible. And so this makes the problem of the self-driving car really hard. And so one solution to this is say, hey, we got to build something that can figure all these things out. It can figure out like, what do I do with all of this complexity? The other solution, though, is to make this simpler and to build roads that actually kind of make the self-driving car part easier. This is Minority Report. They're driving kind of crazy little, I don't know what those things are. But the roads here obviously make that problem simpler. Like we could design roads in such a way that the self-driving thing is actually much easier because they're not having to deal with the stuff that we as humans deal with more easily. And so the same thing could apply to data modeling techniques. Like if we think about all these different semantic models and these different kind of data modeling techniques, they're all mostly designed for us as humans to consume. They're all meant for, okay, what do we as people, as the people on the other side of these things, actually want to do with it? And can we make sense of it? But it's entirely possible that if these things are primarily being consumed by AIs or by like LLMs or things like that, these models may not actually be right. Like the roads that we want to drive on as humans may not look the same as the roads that a self-driving car wants to drive on. The same may be true for any kind of like model that wants to consume data. It may not be the thing that it reasons in a human way. It may reason in a very different way, and therefore the model might need to actually fit that better. An example of that, so again, kind of this, like it may be that if our concept of chess is too limited, that also suggests that perhaps the way that we model chess is too limited. So we should potentially model that in a different way. Another way to kind of think about this is actually around how you can think about data itself. So this is a CSV. Actually, I think it's like a type separated file. I don't know if that's actually a type, but that's what this is. This is FEC data. So it's like donations to political candidates. Shout out George Santos. So this is actual data. This is the way that we as humans might consume this. Like you download a CSV, you can read it. You know what it means. Like we can look this up. Cool. As a computer, though, if you want to do analysis on this data, it's actually better like this. So this is what happens if you turn that file into a Parquet file and open it up in a text editor. Like I have no idea what this means. Nobody here has any idea what this means. But if you are a computer or a database or DuckDB that is trying to reason your way through this data, this is a far better way for it to look at it. And so you could imagine semantic models, again, operating kind of in a similar way, where the fact that we can't make sense of them doesn't actually mean they're worse. It means that for whatever is consuming it, it actually can make a lot more sense of it in the same way that certain databases can understand this a lot better than it can understand that other thing. So that gets me to the third thing, the last thing I'll talk about here, which is actually maybe we get rid of semantic models altogether. Maybe we don't need them at all, which may be a crazy thing to say at this conference, but there's a world to me in which this is actually possible. And so to explain this, I want to start with this guy. So this is W. Edwards Deming. He's like a famous management theorist. He talks a lot about like the theory of the firm and things like that. And so he had this idea of like, what is knowledge? Like, what does it actually mean for an organization to know something? And the way that he puts this is that his criteria for what knowledge is whether or not it helps us predict stuff. That if it is predictive, if we can use it to tell what's going to happen next, then it is knowledge. If we don't, then it's not. And so like, it's not a matter of discovering things that are true or aren't true. It's just a matter of understanding whether or not something actually tells us what's going to happen or not. And so I want to then talk about this dude. So we take that, put that aside for a sec. This guy, his name is Rich Sutton. He's like one of the early creators of various AI things. He's actually an AI expert, unlike myself. And so he actually talked about what the implications of this might be in a blog post that is called The Bitter Lesson, which he puts it way better than I actually do. And so I actually kind of do an obnoxious thing and quote this at length and just kind of read some stuff on slides for y'all. But again, it tells this way better than I would. So he says that the biggest lesson that can be read from 70 years of AI research is that general methods that leverage computation are ultimately the most effective and by a very large margin. In chess, Go, speech recognition, and so on, and other things, researchers have always tried to make systems that work the way researchers thought their own minds worked. So they tried to put knowledge in those systems, but that ultimately proved counterproductive and a colossal waste of researchers' time When through Moore's law, massive computation became available and a means was found to put it to good use. It goes on, the bitter lesson that is based on the historical observation is that AI researchers have often tried to build knowledge in their agents. This always helps in the short term and is personally satisfying to the researcher, but in the long run, it plateaus and even inhibits further progress, and breakthrough progress eventually arrives by opposing approach based on scaling computation. So basically, what he's saying is what we do is we throw a bunch of like numbers and data at these problems, and that solves them way better than trying to actually like imbue any sort of knowledge into the system. That we don't beat chess by trying to teach a computer how to play chess. We beat chess by giving it a whole bunch of games or letting it just play itself for a whole bunch of times and say, you figure out what to do. And that is also true for like poker. This is basically how we beat poker in the sense that we didn't teach it anything about the rules of poker. We basically said, play a bunch of games, you figure it out, and it figured it out. And so it wasn't trying to teach the strategies that we actually have. It was trying to just say, hey, like you devise your own strategies and we won't try to apply our knowledge to it. You figure out what's right. And so, you know, I think, again, this is somewhat of an uncomfortable thing to potentially believe, that actually the way that businesses might want to make decisions, the way we might want to understand the world is through just like raw computation and this kind of inelegant brute force. But that is often how these things actually advance. And so kind of going back to his post, one of the things he says is like this comfort is a big part of the process, where the eventual success that we have from these kind of computational models is often stuff that we incompletely digest because it feels like it's a failure over these kind of favored human-centric approaches. We want to make the computers think the way that we do. But we actually want AI agents that can discover like we can, that don't need to contain what we have discovered. It doesn't matter what we have learned, and we don't need to teach AIs those things. We instead just want them to act the way that we do. And so I think like that really is ultimately the point here, is that what we're trying to solve is this kind of prime number maze. We can't actually solve it ourselves. And it may be that the best way to do this is actually the way that you know, these poker games have figured it out, the way that chess has figured it out, all these things, which is not to try to teach it how to play. It's not to teach it the semantic models of our business or the ways that we think about reasoning about it, but instead to just give it a bunch of data about those things and have it try to figure it out on its own. And in that case, again, the kind of semantic model fully goes away. So I'll stop there. If you want more angry, grouchy things, you can go here. I have no idea what time it is. I'll stop for questions.
So which one do you want? First, second, or third?
I mean, like,
Which one do you want it, and which one do you think it's going to be?
I mean, I think it'll be the third. Like, honestly, I think we will figure out, not like, we're not going to sort of solve all the problems of the world, but I think that approach to things where we basically find new patterns and stuff that don't necessarily make sense in our relatively elementary theories of how these systems work. I think we will find that through these sorts of things. I mean, that blog post is really good. I would encourage folks to read it. If you just Google The Bitter Lesson, Rich Sutton, you'll find it. It's not very long. There's another part in there that basically is like our attempts to model so many of the things we model. The reasons they fail is because they are inherently unmodeled. Like the complexity is too much. We attempt to do it because it's the only way we can reason about it. But actually, like we want to throw most of that away because it actually becomes a very limiting thing once you have sort of more computational power to bear. Yeah.
Great.
Yeah.
Cool. Thanks for the talk. Very interesting. So if we assume what you're saying is correct, and there are models that we cannot perceive for whatever reason, AI on its own can solve very difficult problems just by looking at them in a different way. There's still a problem of transparency when it comes to our understanding of what machines are doing. So how do we trust the models that we deploy or are deployed by AI when we don't really understand what's going on?
So there's probably two ways to answer that. There's like an ethical way, which is like, do we trust it? Do we trust the diagnosis the AI doctor gives us? And like, we have no idea why, but it seems like it works. Let's do it. I don't know. We probably don't. Like, honestly, I think in those cases, we probably actually don't use it. But the other point is that the Deming point. The Deming point is basically like, look, the whole point of this stuff is predictive. And if it's predictive, then it's useful. If it's not predictive, it's not. And not predictive in the sense of like, we need to have forecasts for sales, but his sense of like, if we think we know something, the reason that is valuable, at least in a business context, is because we think we know what's going to happen next. That we can say like, it doesn't do us any good just to have a perfect sort of theory of the world that doesn't tell if it's going to rain tomorrow. But we could have no idea what weather patterns are like define what. But if we can know if it's going to rain tomorrow, that's a way more valuable thing. And so I think like if we find these sorts of things that even we can't understand, but they seem to work, I suspect we'll use them. Like again, the poker players that are sort of blindly following this thing or attempting to, they would rather play the way the machine does than understand it and like attempt to derive meaning from it. At least that's my, sort of elementary understanding. Yeah. Okay.
So great talk. I love the material. So I actually tend to agree with you that even though I'm knowledge around business, I tend to agree with you that the more we let the machines sort of figure, we under constrain the machines and let them figure it out. In the long term, the better off we're going to be. But even in the third scenario, you still have to tell the machine what the rules of poker are. The machine has to know about players and cards and rules and what winning means and what losing means and what you're maximizing for, which is you want to make more money in poker or chess or all of these things. So if you want to map that to business is a game where money comes in and hopefully more money comes out. And you have to operate within constraints of the law and morality and all the things you decide are the rules of the game. And so you have to still have a symbolic representation for the what, but what you don't want is symbolic or you don't want the how we play business to influence the machine, but with the definition of business is something that the machine is doing.
So I would agree in practice, not necessarily in theory. So there are other sort of these AIs that will play games. They don't actually tell them the rules. They basically tell them like the thing to like, it's like play Mario. Teach an AI to play Mario. They tell it literally nothing other than like get to the end. That's it. Like you won or lost. And it figures out like the actual rules of the game on its own. And so I think actually like you don't necessarily even in some cases need to teach it that much. You basically teach it like what is the desired outcome. That's it. So it's like make more money, go figure it out. Now I think the problem with businesses, which is the problem of all this stuff and how this probably doesn't work, is you can't play a business a billion times. Like I don't actually know how you sort of simulate that. But I would imagine there are ways that we figure out some of that. Whether I don't know what that looks like. Maybe it's like we have to now derive a bunch of models for the sake of the simulation, and then we go apply them. I don't know, but it seems possible to me there is something there that plays out. But I think that to me is the much harder problem of like, what do you play 1 trillion times if you're a Coca-Cola? I don't know. I guess you sell a bunch of cans of Coke. Y'all both have questions. I have 45 seconds according to this. I don't know if this is right.
You have a little bit more time.
Okay. Go ahead.
I was just gonna ask a follow-up and to say, could this be an analogy that we can maybe predict weather, but are we predicting climate change and those, since they're, whether we see a prediction and we see how well we do multiple times and longer time horizons. So just thinking about, to your point, business simulations, also sort of domains where there are shorter versus longer horizons and more or fewer sort of examples. So
Yeah.
it could be a hybrid world depending on timescales or open space.
Yeah, I would imagine there are ways that this actually could be applied to Amazon much more easily than it could, or Facebook or whatever, much more easily than it could be applied to enterprise data startup that has 15 customers. Like I don't know what that company does, but it may be that there are ways sort of similar to the poker bit where I could have never played poker before, but still kind of learn from this thing that has found kind of new ways that these things operate. That we start to reason about it in that way. And I think the weather thing is interesting too, where to the point that the Rich Sutton made, attempting to model weather is very hard. Like that is a notoriously very difficult thing to model, like the atmosphere. However, we may actually do a better job of trying to figure out weather patterns by just saying, here is a bunch of weather data. Tell me what's going to happen next. You don't have to have any sort of understanding of how weather systems work. It's just a matter of, okay, based on these inputs, go tell me what's next. They seem to work reasonably well in that way. So,
I think there was another question.
yeah.
Well, it's more just an observation that, even in the 19th century, Thoreau was saying, man, we've become the tools of their tools. And so, future number 3 seems to be the way to bet.
Yeah.
That's the video section revolution. So he's going to say, those sites, like, logic, taking models, so that's why
So I'm out of my depth. I'm out of my depth like 2 slides into this thing. My guess is, again, kind of going back to the ways I've seen it play out, is this thing's, there is a human tendency, I'd imagine, to always want to model it and understand what it's doing. And you see that again with like the chess piece, where like people are trying to understand, what does it see? What is it like? Okay, I can understand why it does that and it wins, but like why? And so my suspicion is if this stuff actually does get applied in other places, we will always attempt to understand like what was the model behind it. And so, that to me would make sense, is like, oh, we find new models of sort of, it is going from like, rather than the theoretical to the empirical, like the empirical to the theoretical, and trying to sort of retrofit some theory to it. Whether or not that works or not, I don't know. And again, I'm talking well beyond anything I know about at this point.
Any last question?
Yeah.
What is analysis within I went, right? And for the audience here, I'd like to remind them that the first car in 1899 was electric, but it took, 100 years more to get it to an electric car. And meanwhile, it was useful to develop gasoline cars.
Yeah, I mean, certainly, I don't know like timelines. I don't even know if this stuff is going to happen. My God, I have no idea what timelines here are. And I am sure it is something that happens in different ways. Like, okay, we did this with chess 20 years ago. When do we do it with like marketing automation? Probably not that long from now. When do we do it with like strategic decision making? When Amazon decides what companies to acquire? Never, probably. Like, that's probably some emotional Jeff Bezos decision. Then he wakes up one morning and decides he wants to buy a rocket ship. I don't know. So yeah, I certainly, yeah, or a newspaper or a sports team that they won't let them buy or whatever. Yeah.
So let's say AI kind of new ways to learn based on its compute power, which we don't have. Can it teach us in some way to learn, or do we outsource learning to AI?
I have no idea.
I like asking easy questions.
Yeah, that probably is a whole bunch of like, it's like a philosophical question, probably like, what does it mean to learn? I don't know. I have become sort of a doomer about this stuff. Like, I think it's not going to like come Skynet, but like those sorts of things actually, and like the capabilities that it could have, I think we are not sort of ready for as society. Society has built a bunch of roads that are designed for humans, and we're going to very quickly have a bunch of cars that try to do different things. And like, I don't know how we deal with that. Like, I don't know how you be like a 14-year-old right now. So I think, but a lot of those sorts of things of like, do we try to learn from it? What does it mean to learn from it? That sort of stuff, I think, is going to be like a really difficult thing to grapple with, just broadly, regardless of what that has to do with knowledge graphs.
All right, thank you so much.
Yeah, for sure. Yeah, it's all good. Yeah. Yeah, great.